Alrighty, section 1.4, stretches and compressions. So we're going to focus just on the vertical stretch and compression first. So I'm going to say let g of x equal a, and I'm going to add a little notation here. A times f of x. You're multiplying f of x, the whole function, by some value a. So then the graph of g is obtained by taking the old graph of f, whatever we used to have, and it's going to be doing a vertical stretch, so things are going to get drawn out vertically if the a value is greater than 1, and it's a compression if the a value is between 0 and 1, so 0 less than a less than 1. Now, stretches and compressions are going to change the points that the distance is a vertical stretch compression, to be specific, changes the point that the distance is away from the x-axis by a factor of a. So for example, if g of x equals 2 times f of x, and there's a point on function f of 5, so the point 5, 3. So let me label that on here. So this is the point from function f, so 5, f of 5 equals 3. So that's the point. Then g of 5 is going to be twice that. We're going to take whatever the output is when we do f of 5 equals 3, and we're going to double that. So it's going to be g of 5, and we're going to get doubled height. We're going to get 6. So we kind of think of that point 5, 3 as being stretched away from the x-axis. So it's being like this used to have a distance of 3, now it's being doubled, so now it has a distance of 6 away from the x-axis. Let's take a look at an example down at the bottom here. So we've got two functions, f and g, and they're shown below. We're asked to describe how they are related. So I'm going to always assume f is the beginning, but we can also describe, or like the starting graph, but we can describe it both ways. So if f is the starting graph, g, it looks like things got shrunk down a little bit, kind of get pushed down. You can also see over here, this is a point on f, and it gets kind of like pushed up towards the x-axis. We're compressing it, we're squishing it down closer and closer to the x-axis. So I'm going to say g of x is a vertical compression of f of x. We take f of x and compress it. Now, by how much? So taking a look at this point up here had a height of 1, 2, 3, 4, 5, 8. So that was like the coordinate 0, 8. This point down here is the coordinate 0, 4. So that's, you look at them like, oh, the difference between 8 and 4 is 4. Well, let's talk about that. This one down here, this has a height of, I'm just going to focus on the height because it's at like a weird 4.5. Let's just say it's at the coordinate 4.5, comma, the height looks kind of close to -2. This coordinate here, this one's at 4.5, comma, -1. So the change, the change in the heights needs to be the same. So we can't say, oh, you took 8 and subtracted 4 and get 4. We're going to say you take 8, multiply it by 1/2 and got 4. So we're going to say it's a vertical compression by a factor of 1/2. You could go the other way, and you could say f of x is a vertical stretch, and I'm going to abbreviate vertical as vert. Vertical stretch of g of x by a factor of 2. Let me shift that a little bit. So we could say f of x is a, wow, I cannot get that on the screen. Sorry, f of x is a vertical stretch of g of x by a factor of 2. I typically will go from f to g, so what did we do to f of x to get to g? All right, let's take a look at an example where we actually are dealing with some coordinates. So it says use the table to identify the points and sketch the graphs of f of x equals x squared and g of x equals 2 times f of x on the same graph. So we're starting off with f of x equals x squared. So just like we've done in the past, let me zoom in a little bit. Let's use some of those easier x values to plug in. Let's do -2, -1, 0, 1, and 2. So when we take each of those and square it, we end up with -2 squared is +4, -1 squared is +1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And let's just plot those, and this graph should look moderately familiar to you. Sorry, there's a helicopter going on overhead. You might be able to hear that. So coordinate at -2, 4. -1, 1, 0, 0, 1, 1, and 2, 4. And we'll connect those dots, make that nice, smooth parabola. That looks something like this. And for consistency's sake, let's label it as f of x. Now g of x, it's 2 times f of x, so it's going to be 2 times the x squared. Now, before we go any further, I want to actually think about the specific things that are happening to our coordinates, and that's where the rule is going to come into play. You may remember the rule from the previous section. So the rule, x, y, those are the starting x coordinates of, the x and y coordinates of f of x. Sorry, let me make sure I'm using the same colors to be consistent. So f of x we're doing in red. But then g of x is 2 times that. Now, it's a vertical stretch. Now, vertical is dealing with the y value, so it's going to be stretched out vertically. So it's going to be, the x value doesn't change. The y values are going to be doubled. So this is for our g of x. So f of x transforms into g of x by taking each y value and doubling it. Now, let me again make sure I'm using the same colors. It's okay if you don't use the same colors as I do. We're going to do 2 times x squared. So if we use -2, -1, 0, 1, and 2, if we did this correctly, the y value should just double. So let's just double check this. So when we plug in -2 here, we're going to get +4 when we square it. And then we double it, and we get +8. Plugging in -1, we'll do -1 squared, giving us +1, doubling it, giving us 2. Taking 0, squaring it, doubling it, we get 0. 1 squared is 1, double that, you still get 2. And then 2 squared is 4, double that, we end up with 8. So let's plot these points. So -2, 8, it's going to be 2 to the left, 8 up, so that's right there. -1, 2, it's going to be 1 to the left, 2 up. 0, 0 didn't change. 1, 2, and 2, 8. Now, if you're visualizing this, it's kind of like each of these points got stretched out twice as tall as they used to be. Now, the 0, 0 point didn't get stretched at all, and that was a really crummy parabola edge right there. That 0, 0 point didn't get stretched at all because if you're doubling the distance away from the x-axis, doubling 0 is still 0. The distance hasn't changed.